So I always get asked the question, well, you know, everybody thinks you're at the fate of your genes. Absolutely not true. So what does genetics have to do with it? As we age, genetics plays a much smaller role in how we age, when we age. Our genes are turned on by our environment. Our environment tells our genes to either degenerate or regenerate. So what do you want to tell your genes? You're going to tell them to degenerate or regenerate? Regenerate. Okay, I've got a good audience here. Well, you know, they did some studies in these areas where people live well into their hundreds, and they're healthy 100s. The 100-year-olds in some of these places can do what our 30-year-olds are doing. And they're out there chopping wood, climbing hills, you know, farming, dealing with the gardens and life in general, and they're living healthily. It's not how long you live, it's how healthy you live long. So what they found in these blue zones is it has nothing to do with genetics. Some of them, yes, there's genetic homogeneity, meaning people are pretty much from the same gene pool, but we have a community in Loma Linda, California. Because you can say, yes, out in Sardinia, where it's beautiful and it's peaceful, they don't have the stresses that we have here, and they have all that fresh, healthy food, and they don't have, you know, fast food, and they don't have to sit in offices. Well, it's not just Sardinia and one of the Greek islands in Okinawa. We have a community here in Loma Linda, California, where centenarians live longer. And what they found is these people had a sense of purpose, they have a sense of community, they live a healthy lifestyle, they exercise, and it's not exercise necessarily in a gym. They eat healthy, and they eat more of a Mediterranean style diet. So we know that environment plays a huge role in how we age and what we tell our genes. Because even if you have a gene for cancer or for some terrible disease, that gene is like a seed. If you don't feed a seed sunlight, water, and proper soil, it's not going to grow. So if you don't send the signal to your gene to turn on and degenerate or form some kind of disease, you're not going to get the disease. You really have a lot of control over that. So what's the difference now? We have an exciting new field of anti-aging and regenerative medicine. There are breakthroughs in technology now to tell us what our genes, we can map the entire genome, but you can also map your own individuality. You know, we have what they call single nucleotide polymorphisms, or short SNPs. In medicine, we have to have a lot of abbreviations. Could you imagine trying to talk about single nucleotide polymorphisms? Try that fast. Well, anyway, these SNPs are what make all of you very different. You know, you sit around, you know, having coffee with your friends, and one will say, oh, that disturbs me, or I can eat wheat, and you can't eat wheat, and this person can eat dairy, and that person can't eat dairy. Well, what's the story here? Well, we all have our own way of metabolizing things. So the good news is there's a lot of things that we can do to measure that. That's the breakthrough in anti-aging medicine. We have receptors that allow things to get into the cells and tell things to get out of the cells. We have cellular communication. Our bodies really are programmed quite well to communicate with all the other parts. It's when we mess it up with saturated fats and trans fats and break down the communications that things go wrong. But the exciting part of anti-aging and regenerative medicine is we can start looking into your own unique metabolism. You know, for example, some people cannot activate their B vitamins. That's one of the most common single nucleotide polymorphism. That's the most common SNP, is you can't activate the B vitamins. So what do? You give somebody activated B vitamins. It's as simple as that. Not everything is that clear cut and that simple, but knowing your own unique vulnerabilities and metabolism is extremely important.